Well, hello and welcome. In this presentation, we will be looking at annuities. An annuity is a financial product which provides you with a series of regular payments in return for a lump sum investment. It's effectively the opposite situation to a reducing balance loan. The recurrence relation, the value of our next term, equals RVN minus D. It will increase due to the interest calculation based on the value of VN, and it will decrease due to money being withdrawn from the investment. Now, in this situation, AJ invests $1,000 into an annuity with a compounding interest rate of 5% per annum. He organises for a regular repayment of $100 per year. You can follow the maths here, but basically he starts with 1,000 and then his annuity, or basically his money, will increase by 5%, but also decrease by the amount that he is repaid. And this pattern will go on and on and on forever. Well, not forever, but until he has no money left in his annuity. It has a recurrence rule, which will be 1.05 multiplied by VN minus 100. Actually, it's a recurrence relation. We can't say there is a recurrence rule. It's just too complex to worry about. And this information can be represented on an amortization table. Again, I briefly explained what was going on here, but for each period, you will receive a payment and interest will be calculated, and a new principal, a new change in your balance will be calculated, and then your balance will be adjusted accordingly. Now, this is basically solved on the TI-Nspire calculator, and what we can do here is basically populate the fields that are available to us on our calculator. N being the number of payments, I is the annual interest rate, PV is the present value of the loan, or in this case it would be the present value of our investment. Payment is the amount that we receive coming back to us from the investment. Future value is how much will be within our investment or in our investment at its completion. PPY, CPY, how frequently our calculations to interest and payments are made per year, and payment at, we just leave that to set to end. Now, just as I mentioned in the previous presentation, you must consider the sign of PV, payment, and future value. So, let's look at the situation here with Lavinia. I will just jump to the next slide. And you'll see here Lavinia invests $200,000 at 4.5% per annum. Interest is compounding every month. What will her monthly repayments be if her annuity is paid out in 20 years? Now, what I need to do is decide, what is this question asking me? It's really asking me, what's her monthly repayment? This is the field here that I need to populate. Well, I need to calculate it to calculate. So what I have to do is populate all the other fields. Now, straight up, we know we have 20 years and we're compounding every month. So the number of compounding periods will be 20 times 12, our interest rate, 4.5%. Now, PV, present value. Now you'll notice here, negative 200,000. What's happening there? Initially, Lavinia has supplied 200,000 to the investment company. Right. Future value, well, at the end, Lavinia does not expect to have any money left as part of her investment, and there are 12 payments or calculations per year. Put all these values in, and the payment will be 12,650. What you'll notice here, the sign here is positive, indicating $1,265.30 is coming Lavinia's way from the financial institution every month, and that will happen for 20 years. So what you'll notice, if you remember, compare this with the previous video, everything's identical other than the signs. Originally it was a positive 200,000 and a negative 12,650. They've just flipped around. Now, likewise, okay, the interest rate may change on the annuity. Very unlikely though, if you read the note. Most annuities, they guaranteed their particular interest rate. What's happened after the 10 years? The interest rate has been bumped up to 5.5%. So what we need to do is effectively we work out our repayment, and that's the repayment that's happened for the first 10 years. We'll be able to then calculate how much is left in Lavinia's investment after the 10 years. Then we consider this to be a whole new investment. So for the second 10 years, she will have this value here, 122,087 and 82 cents. This interest rate actually should be 5.5%. Just my mistake there. And when we work our way through that, you'll notice that with the interest rate that's gone up, she will have a higher payment. This time the repayment to her will be $13.24 and 97 cents. So there you have it. Hopefully you can notice the similarities between annuities and reducing balance loans. So until next time, good maths and bye for now.